Welcome back. In the previous videos, we covered the concept of support vector machine, the linear polynomial, as well as the radar basis function. We can see that the RBF actually performed the best amongst all the different kernel available. Obviously, there are other kernel available, like such as sigmoid, but we won't go into that here, and also custom as well. Again, we won't go into that here. I'm going to leave it to you to actually explore those. I think there's already enough sufficient foundation for you to actually start exploring those on your own now. What I want to cover in this lesson really is support vector regression. Now, you probably would still recall the Boston housing datasets. Now, you should be very familiar with it because in the regression modules segment, we went through the Boston datasets very thoroughly and in details. We look at multiple regressions. We also look at the various different application of the machine learning algorithm on it, including non-linear ones such as random forests. What I do want to do now is to actually just illustrate that support vector regression. It will be interesting to see how well it performs under this setting. Right, obviously regression is a little bit different from classification. So first of all, we need to import the support vector regression. We also need to import the relevant matrix that comes with regression, such as mean square error, such as R2 or R square. Obviously, there are others. For now, this is really sufficient for our purpose. Again, we're not using all of the parameters. We're just looking at else, STA, and else stat. We fit our model, and this is what it looks like. And let's plot that out. And this is the interesting part. And what you can obviously see here, there's actually a classic case of overfitting. It's all over the place. And let's see if the so-called performance is likewise the same. Okay, and this time around, we're going to run it on a linear kernel. Let's run this and have a look. Okay, we fit that. We're going to run our prediction and also the test prediction. And let's see what our mean square error is, as well as the R square. Not really impressive, obviously. Under the train, the test improved. Well, the train score is really high. The test score obviously is not much better, although it did drop. In terms of R square, 52% is nothing to boast about. Test score dropped further as well. Let's have a look at if we use a polynomial kernel, and let's see what it looks like. We'll run the prediction again, and let's have a look at the matrix and see what kind of score we can actually obtain from that. This might take a while. If it takes too long, I'm going to just speed up the video. Alright, welcome back. Well, definitely it's not impressive at all. I don't think I need to actually go through the score. The R square is minus and negative. Let's look at kernel. And alright, again, this performed the best amongst the three. Funny enough, polynomial, the sequences are same. RBF is the best, followed by linear, and then finally polynomial. And clearly what you can see here is that the kernel has done better. Again, one of the things that I do want to stress is that there are a couple of best practices we did not apply here, one of them being scaling the actual features itself. Remember, support vector machine is really sensitive to scaling. But this is just a first run, just to actually see what it looks like. Not impressive, of course, but nevertheless, it's a useful exercise just to actually, so that we can actually get a hang of what it looks like. What I would like you to do before we end this lesson is for you to actually run the whole three process again, except you scale it. All right, so time to pause the video. When you come back, I'll wrap up the lesson. Welcome back. I hope you actually try that out and get a feel, and be interested to let me know to know how well how did it go. If you can, post it on the Q&A section and let me know what your scores are. Did it improve for all three, linear, kernel, as well as the polynomial? I think it would be good for you to actually post it so that we can actually get a discussion going in the forum itself. Right, clearly what we have shown here in this tutorial or this video lessons is that support vector machine is not just for classification, but you can also apply it into regression as well. There is actually one more thing that we haven't illustrated so far, and we will cover that in future lessons. Basically, I mentioned here, where was it? I mentioned in one of these lines here. Yes, you can apply the classification. We've shown you how it can be done in regression. In future videos, we're going to show you how you can actually apply this to outliers detection as well. With that, I'm going to end this lesson. When we come back, I'm going to cover the advantages as well as disadvantages of SVM, as well as summarize some of the key points before we wrap up the SVM section. I look forward to seeing you in the next video. Thank you for watching.